Senhores, eu vou passar para o Andrés. O Andrés ele criou o w3af, uma ferramenta open source para teste de vulnerabilidades web. Então ele vai apresentar sobre essa ferramenta. A ferramenta é uma ferramenta open source, está disponível para qualquer um. Ele vai explicar o processo, a ferramenta e assim por diante. Espero que vocês gostem.
Thank you. So, okay, I'm going to be talking about w3af. First, 2 minutes about me. My name is Riancho, and I'm a web application security enthusiast. I work with web application security every day, and I enjoy it. Okay, I like it. It's fun. You get in, you get your root, you get your information, so it's fun. I develop in Python. I started developing in Python like 5 years ago, and I must say that I'm not ashamed of having Python as my main language. I use open source, I preach about open source, and I like open source. So that's why I'm an open source evangelist. I'm the w3af project leader. This is a project that has 3 years of life, and I'm the founder of Bonsai Information Security. It's my own company. I founded it 10 months ago. So, raise your hands. Who works in web application security? Only one? Come on. Don't be lazy, come on. Yeah, okay. So, who heard about w3af? Right, excellent. So, more people heard about w3af than the ones that work in web application security? That doesn't make much sense. So, who used w3af? Once, okay. Great, excellent. We have 10 people. Who tried to read the source code? Somebody? Okay, 2, nice. And who changed the source code? Out of the 2, none? Okay. And who's in favor of drinking heavily? Yeah? Okay. More of you? I guess so. So, w3af, it's basically web application attack and audit framework. It's a tool that will audit your web application, will find the vulnerabilities, and will exploit those vulnerabilities. Okay? That's the main idea. It's an open source project. Its license is GPL version 2. And basically it's a set of scripts which evolved into a serious project. I was working in a company. That company has had a policy about buying commercial tools, which was don't buy commercial tools. So I had a lot of scripts laying around, and those scripts were a pain in the ass to maintain. So I started to work on a bigger project, which is basically that. It's a vulnerability scanner, an exploitation tool, and a set of manual analysis tools. I also did this because no other open source tool was good for my day-to-day work. Okay? Maybe it was for others, it wasn't for me, so I started to write my own tool. It identifies almost all web application vulnerabilities that can be identified in an automated way. You guys need to understand that maybe, I don't know, 70 to 80% of the vulnerabilities can be identified in an automated way, and the rest is on you, okay? The brain of the penetration tester needs to be in the penetration testing process. It's cross-platform, it is written in Python, and we have a console user interface and a GTK console user, and a GTK user interface. And it's really easy to extend. Over these 3 years, we had something like 40 developers, which contributed with different pieces of code, mainly plugins. We're going to see what a plugin is. And we use different types of discovery methods. For example, we use some tactical exploitation things. We can exploit blind SQL injections, OS commanding, remote file include. We have different exploits, and those exploits are generic, okay? We're going to see that later. The plugins work together. The plugins each plugin, for example, we have a plugin that finds SQL injection, and we have another plugin that is going to spider the website, okay? All of those plugins exchange information and work together to get your task done. And your task is to enter that application, okay? To break into that application. Okay, and of course we have manual and automated analysis of web applications. We have 3 different tools, or actually 4 or 5, inside the graphical user interface, which are going to be really useful for you when doing a manual analysis. The project is split into 2 big things: the manual analysis and the automated scanner. Okay? Of course, the manual analysis is for you to use and click over the interface, and the automated thing is like, okay, that website, I want to know all the SQL injections. Do it. And that's the work of the automated part. So I like demos, and so I'm going to do some demos. This, of course, is the demo about the graphical user interface tools. I haven't really prepared the demo, but let's see what happens. Now I'm starting the graphical user interface for w3af. That is starting, okay. It takes a while because just like in Metasploit, it loads all the plugins at the beginning. And this is how it looks, okay? This is how you see w3af, which, if we zoom in, we can see better. We have, for example, of course, the target that we want to set up, and the different plugins that we want to enable. But this demo is not about that. This demo is about these tools. We have a manual request editor, which basically you say, okay, send this request to this server, nothing special. And we have a fuzzy request editor. This means that we're going to use something like this. We're going to define a syntaxes. Yeah, you see it here in the X range. So we are defining one request like this, which is going to send 10 different requests. Anything that's between the $signs is going to be run as Python. And if it returns a list, it's going to create different requests based on the values in that list. Okay? So in this case, it's going to request localhost and 0, 1, 2, 3 until 9. Let's do it. You define your syntaxes, and you go to play. It's going to send all of the requests. And here you see the first one that was generated and sent with the 0. You see the next one with the 1, and so on. Also, you can see the response and do some other analysis. But in cases like this, you're trying to find something. You're trying to find usually the one that's different. You're trying to, if I do something like this, send 10 requests, I don't really care about all of the responses. I care about the one which is different. So how do I do that? I go to cluster responses, which is right here, a little button at the bottom. And I say that I want to cluster the responses. Clustering is grouping, okay? We have different ways of grouping. You can analyze that later. So after we say cluster, this is what we get. And oh, yes, it looks like this guy, which is here, is completely different from this group, okay? And believe me, if you're doing this with 1,000 requests, it's going to be really good, because you don't want to search this one between 1,000 manually, okay? And of course, this grouping is made automatically. You don't have to do anything. If we click here, we see in the response that we have a 200. This is the different one. And in here we see, of course, that these are 404. The comparison is not done only by the code in the response, it's done by the body. Okay, this was compared, the response body. Okay, so this was the fuzzy request editor. We also have some other tools, but the one I want to show you is the man-in-the-middle proxy. It's just like, I don't know, burp, okay? But it has one nice feature, which is that you can analyze a specific request. So, I have a URL, which I know has cross-site scripting. But let w3af find that cross-site scripting. We're going to set in the browser, we set the proxy to w3af proxy, and we request that URL. We see how the request was trapped here, yeah? And we send the request. Now that we send the request, we go to the history, and we see this original request, yeah? This original request, you have that parameter, which is text. So now what I want to do is to find cross-site scriptings in that specific request. So let's do it. I just go here and say, there's a little button there which says audit request. Click there. Click there, and a big list of all the things that you can apply to that request appears. So I say cross-site scripting, and it will apply the cross-site scripting detection to that request. After some time of running, it will be in the response. It will say, it will tag one of the requests as cross-site scripting. I click there, and if I go to the info, I see that cross-site scripting was found, yada, 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 okay? So in this case, if you're doing a manual analysis, and you see one request that you might think that is vulnerable to something, you just test it with w3af. You say, to this request, apply all of the audit plugins, and SQL injection, remote file inclusion, OS commanding, local file inclusion, anything you can find in this way. Okay. If you have any questions at any time, just raise your hand and I'll answer them. Okay, so this was the graphical user interface tools demo. And something really, really, really important for me is that we have an active community. This is not just a project that I am trying to push. We have an active community of developers that are contributing with source code, which are contributing with bug fixes, okay? And this active community created the whole project. So I'm going to show you a video representation of all the contributions. That's not the video representation. Let's see what happens. Okay, let's try again. I'm not sure that if you can see this, but basically, there you have my name, okay? Andres Riancho, with some little dots that you see around my name. Every dot that you see is a file that I changed and committed to the SVN, okay? So, in 2007, I was working alone, and I was making a lot of changes to a lot of files. Those are the dots that you see. And at some point, I got Facundo Batista to help me with the graphical user interface. So his name appears. Then Sharagna appears, which is a contributor from India. He did not contribute that much, and that's why he disappears. Then we have Alexander Bersnoy from Russia. He's doing the console user interface for the framework. Then we have Ulises. He did some work with the Windows installer for w3af. And all that you see here is changes. These guys have SVN commit for w3af. And they are changing things, okay? Okay, what else? At some point you're going to see like really big, that one, yeah, two balls that separate. That's a branch in the SVN. We do branches. We try to keep things ordered. H2HC, it's Taras Ivanishenko from Russia also. So in here you see a good representation of an active project. Yeah? I'm not going to play this until the end because we just need to recover some time. But you get the idea, right? Okay. So w3af is divided into two main parts internally, right? Two different parts, the core and the plugins. Each plugin is going to do one task and do it well. Like SQL injection detection is one plugin. Cross-site scripting detection, another plugin. And the core, of course, gives different features to the plugins, like authentication and, I don't know, cookies, session management, things like that. And the core coordinates the process. The core is going to call each plugin in order to be able to find the vulnerabilities. Okay, and also we have plugins that are going to exploit the vulnerabilities. Once the vulnerabilities are found, we want to exploit them, and of course, we do it. We have 8 different types of plugins. Discovery, audit, grep, and attack are the main ones. But we also have, for example, brute force. It's going to, of course, brute force the logins in the web application. We support form login and basic authentication. Evasion is trying to modify each request generated by the plugins to evade IPS or WAF detection. Output is going to write all of the information, like the vulnerabilities found and so on, to a disk, to a file, sorry. XML, HTML, text files, we support all of them. Discovery is this. Discovery creates a map, because if you are not able to find one section of one website, you won't be able to find the vulnerabilities in that section, okay? We have in mind that link coverage is really important, because if you don't find that section, audit plugins are not going to audit that section. Yeah, that makes sense? So we have in the discovery plugins, we have something like 40 plugins, something like that. And like the main one is Web Spider, a really simple crawler, which is going to follow links. We have URL Fuzzer, which is going to, for example, if I have, let's say, index.php, it's going to try to find index.zip, index.php.zip, and so on, yeah, with different extensions, and it's trying to find those modifications of the original URL. Google Spider uses Google to find resources, and Picto is a port of the classic Nicto into Python. Yeah. So those are 4, but we have 40, and they are working okay. Basically, they're running a loop. We have all the plugins which you enable end up in something like this. So you have the plugin A running. It's going to send 5 new links to plugin B. Plugin B finds 5 more. Plugin C finds 5 more. And this is going to run until none of the plugins find anything. Yeah. This is going to take some time. Right now, yes?
Are these HTTP requests only, or do you do FTP?
We do only HTTP requests. And we don't do anything else, because this is a framework based on the idea of analyzing web applications. We're not something generic like Nessus or, I don't know, some other thing. We just want web applications, nothing else. Okay? And that's an advantage. That's an advantage because everything we do is for HTTP. We don't need generic classes for different things, like one vulnerability in Apache and one vulnerability in SendMail and a SQL injection have to be something generic. We are just pointing to the web. Yeah? And these plugins run until nothing else is found. This is going to take some time, and it takes it all depends on the website and how many plugins you enabled. But it can take easily 3 hours. And in the worst case, more than 24 hours. Okay? Something that we have been working on is the performance. Right now, if somebody is interested in solving difficult problems, please contact me, because we have some really difficult problems to solve, like threads locking themselves and performance issues with regular expressions. But if you're into that, please contact me. Okay, and these are some other types of discovery plugins. For example, we have an active filter detection to detect IPS devices. We have fingerprint web application firewall to identify which web application firewall is going to filter our requests. And I'm not going to dig into the refactoring thing. We just have 10 minutes. And I would rather use my 10 minutes in a demo, which is much more beautiful. And we find, of course, once the whole map of the application is there, we're going to find the vulnerabilities. And we find those vulnerabilities using different techniques, because we want to reduce 2 things. We want to reduce the false positive rate and also the false negative. There are some vulnerabilities that you're going to find with errors like this. There are some vulnerabilities like, I don't know, some kind of blind SQL injection, which you can find with different responses. And there are other types, which you need to use time delays. So for every type of vulnerability, we try to use all the techniques. It's going to take more time, but can configure it in any way you want it to reduce that time. And of course, once we find those vulnerabilities, we want to show them to the user, and that's why we save them in something we call the knowledge base. And in this knowledge base, we have, for example, in here, we have cross-site scriptings, which are just there, and if you click, you get all the information about the cross-site scripting. This knowledge base is also used for exchanging information between plugins. So if a plugin finds, for example, that the target website is running PHP, it is going to save it to the knowledge base, and afterwards, if any other plugin needs to know if that website runs PHP or Java, it's going to read that memory location to see if it's PHP or Java. Of course, we exploit the vulnerabilities. Basically, the attack plugins are going to read the vulnerabilities from the knowledge base and exploit them. So let's see what happens. Any questions for now? No? Yes?
Do you save those knowledge bases?
The knowledge base, it's not saved. The information in the knowledge base is saved in log files. It makes sense to save them. At some point in the project, we saved those, but we had some problems, and now we don't save them anymore. Yeah, it's a good question. Okay, now I'm going to show you how this works in an automated way. I'm going to point the scanner to an application. It's going to web spider the application and then identify the vulnerabilities in it. So I'm going to say that I want to audit. Yeah, I'm going to choose which plugins to run. So I say audit everything. Yeah, that's really easy. I'm going to say discovery and go here, and I just want web spider. When you click on a plugin, it's going to show you here the description of what the plugin does, and of course the options. Yeah. In this case, I'm going to set one option, which is only forward, which means only scan things in this directory. Yeah. Save the configuration. I'm going to go for, let me see. Okay. Let's do something really easy. Come on. I still have the proxy. Okay, so in this directory we have 3 really simple to identify vulnerabilities, which are OS commanding, and we are going to say that the target is this one, and it is going to spider it, and it's going to identify the vulnerabilities. So start. When we start, we see a log in here. This log is going to show us all the information that we need, but this log is not really that simple to read. That's why we have the knowledge base. We have a knowledge base browser. This knowledge base browser, you can of course browse it. You go to OS commanding in this case, and you see the vulnerabilities. You click on one of them. You see the description, yeah? It says OS commanding was found at, and the URL, using HTTP GET, and the information that was sent, and so on. And of course, for this, we get the request, and we get the response. Yeah? The same goes for all of the vulnerabilities that were found. If we go to the URLs tab, we see a really nice map of what was found. Yeah? And this map, of course, you can browse like this. You can zoom in, zoom out, and stuff. And you also have it in this more simple format. If we go to exploit, and we say, okay, we have in here we have all the exploits, which are plugins. In here we have the vulnerabilities. And we say, okay, I want to exploit this OS commanding. If I click there, now the OS commanding plugin is in bold letters. I just do drag and drop, and now the exploit was run. A shell object was created. If I click on the shell object, I get a shell window. If I do ls, I get a command. Yeah. Okay, so in one drag and drop, I can exploit a vulnerability. Okay, that's nice. Okay, so from the future, we would like to do something like a live scanner, which is basically a proxy that you're going to be using all the time while you browse any website. And it's going to intercept all of the requests and find in those requests, find vulnerabilities and exploit them automatically. So at some point you're going to go to that application and see that you have 5 shells in different websites that you were browsing, yeah? Without doing anything. We're going to release version 1.0 in a few days, but I'm saying that since April, so don't believe me. And basically the project is growing. I talked with many of you outside, and most of you tell me that you used the project, let's say, 1 year ago, and it crashed all the time. And yes, it crashed all the time. But that was 1 year ago. This last year was mainly bug fixing. So now it is almost stable. You can use it, and it's a 95% guarantee that it won't crash. And if it crashes, just report the bug and I'll fix it in less than 2 days.
Just like Windows.
And we'll have also some performance enhancements to do. And if you want to help, of course, new plugins are always welcome. And of course, I want you to contribute. Yeah, it's a community project. Okay, just if you are into web application security, contribute, help us, and help you. How to contribute? That's a website. Basically, this is what you need to remember: w3af sourceforce.net. If you want to really contribute, attend one of my trainings. And if you really want to contribute, also include w3af in your trainings. If you're a trainer, if you give web application security trainings, include this tool in your training. Questions?
Let me give them just some information. Pessoal, pode perguntar em português que eu traduzo para ele, tá? Quer dizer, se quiser perguntar em inglês também, não tem problema.
Okay, I suppose that there were no questions, so I had suggested questions. Yeah? So, this I already answered. Yeah? It crashed every time, yes, but now it does not crash every time. Is w3af a possible competitor of AppScan, Sensic, and Acunetics? Not now. In 1 year, yes, and in 1 year, they are going to be in trouble. Is going to be open source forever? Yes. And of course, is w3af included in the training I'm going to deliver on Monday and on Tuesday? The answer is yes. So if you're interested in learning more about this, attend my training on Monday and Tuesday. Okay, this is the website. Thank you very much, and contribute. Yeah? Who's like remotely thinking about contributing after this talk? Okay, that guy in the back, that t-shirt is for you. Okay, thank you very much, and see you.